In this video series, we'll cover a short introduction to some core ideas of probability. In statistics courses, basic probability often serves as a transition between descriptive statistics and inferential statistics. You'll see why later when we start to cover some statistical tests and talk a lot about the probability of different things happening. But to begin, let's start with a definition of probability. Now, one definition is that the probability of an event is the proportion of times that the event would be expected to occur in an infinitely long series of identical sampling experiments. Now, the highlighted words here may require a little further definition. By event, we mean the thing that occurs in which you're interested in, whatever it is you want to know the probability of. Now, in introductory probability, we often use examples based on games or gambling because they're clean, straightforward, and easy to understand. It can be kind of fun at times. So along those lines, an event might be being dealt a 21 in blackjack, or rolling a 7 on a pair of dice, or landing on the $100,000 spot on a money wheel. But it can be other things as well, like someone stating that they'll vote for a given candidate, or testing positive for the flu. In contrast, sampling experiments are just how you generate those events. It's being dealt cards in blackjack.
Deal! Hit me! Busted!
Or rolling a pair of dice in a game, or spinning a wheel. Outside of gaming, it's picking a person to complete a survey, or being tested for the flu. So let's start with a very straightforward example, rolling a pair of dice. Here I've created a 6x6 grid that shows the results if someone rolls 2 die. Each row shows a possible roll on die number 1, and each column shows a possible roll on die number 2. So there are 36 different outcomes, right? I can roll a 1 on the first die and a 1 on the second die, or I can roll a 1 on the first die and a 2 on the second, or a 1 on the first and a 3 on the second, or on and on and on, all the way to a 6 on the first and a 5 on the second and a 6 on the first and a 6 on the second, right? 36 possible outcomes. Now, if I'm interested in the sum of the 2 dice, then those sums are the events in which I'm interested. So while we have 36 possible outcomes, we have 11 different events. These events range from a sum of 2, if I roll a 1 and a 1, all the way to a sum of 12 if I roll a 6 and a 6. My events would be a sum of 2 or a sum of 3 up to the event of having a sum of 12. Now, assuming our dice aren't weighted, each of these 36 outcomes has the same chance of occurring. 1 out of 36, right? So the probability of any given event, any specific sum for the 2 dice, is just the proportion of times that total, that event, appears in our 36 outcomes. Now, before doing any calculations, like in all things math, there is some notation we'll use to report probabilities. To illustrate it, let's use the event of rolling a 7. Rather than write out the probability of rolling a 7 over and over and over and over again, you'll see researchers use a capital P followed by whatever the event is in parentheses. So P parenthesis 7 is just shorthand for the probability of getting a 7. Now, you may also see people use a capital P with the event written as a subscript, P sub 7, or an italicized lowercase p with the event as a subscript, or an italicized lowercase p followed by the event in parentheses, right? The key is just to recognize that they're all saying the same thing, the probability of rolling a 7. All right? So what would be the probability of rolling a 7? Well, again, there are 36 different possible outcomes, and 6 of those sum to 7, correct? So the probability of rolling a 7 is just 6 over 36, or 1/6, or 0.166666666. Now what about something else? What would be the probability of rolling an 11? Well, there are 2 ways of rolling 11, right? You can get a 6 on die 1 and a 5 on die 2, or a 5 on die 1 and a 6 on die 2. So the probability of rolling an 11 is just 2 over 36, or 1 over 18, or 0.0555555, right? Now, let's describe what we've just done in stat speak, okay? If all possible outcomes are equally likely, the probability of the occurrence of an event is equal to the proportion of the possible outcomes favoring the event. Now, that may not sound like what we just did, so let's look at it again with an example. Let's say that my event is rolling a 9. This just says that if all possible outcomes are equally likely, well, that just means each of the outcomes has the same chance of occurring. The dice aren't weighted, right? In a more general sense, there's no bias that results in one outcome occurring more than another outcome. Okay? Next, the probability of the occurrence of an event, well, that just means the probability of whatever it is that I'm interested in happening. In this case, it's the probability of rolling a 9. See how they're color-coded, right? Now, that's pretty straightforward, right? Let's keep going. We then have is equal to the proportion of the possible outcomes favoring the event. Well, that just means how many of those 36 possible outcomes added up to 9. We see 4 did, and the probability of each of those 4 possible outcomes is just 1 over 36. Notice the color coding again. So we just add up 1 over 36 plus 1 over 36 plus 1 over 36 plus 1 over 36 4 times, and we get the probability of rolling a 9. That's just 4 over 36, or 1/9. Great. Now, 2 key points so far. One is that the same event may happen in more than one way. I mean, each of these is a different outcome that leads to the same event of rolling a 7. In fact, depending on what you're looking at, there may be thousands of different ways, thousands of different outcomes that all result in the same event. The second is that different events may be associated with wildly different numbers of outcomes. Look at how much variation there is in the number of ways you can get different sums. I mean, the number of ways you can get different events when rolling 2 dice. I mean, there are 6 different ways of rolling a 7, but only 3 ways of rolling a 10, and only 1 way of rolling a 2. Determining how many different outcomes can lead to a given event is really important in probability. Okay? Now, let's stop here for now, but we'll explore that idea deeper in our next video. See you then. Take care.